The idea is that since this side is already been machined and this is straight, we can reference this side to machine this side, because this side, as you can see, is all rough. So the indicator is currently at -0.1. So this is the last pass that we are going to do on this side. We have switched off the camera because these are long boring cuts and we are recording this from our mobile phone. So welcome back. We have regrouped. So we have made this strap clamps arrangement, and now we have got rid of our facing mill and have installed an ER collet. Here is an indicator which you can see over here. This was ideally to check the run out by moving the X and Y axis, but we found that because this is a saw cut, just a hand saw cut, so the accuracy is all over the place. So right now what we are thinking is to just eyeball it in center, machine it, and then indo the part, and then use the dial indicator to finish it off. So for that we need to eyeball it, which we are doing right now, and we need to tighten these strap clamps. All right, we have to bring it approx to center. That is the idea. So I think this would do. We're just giving a little bit of tension on the strap clamps, and we can recheck this. So I think this is within reason. We are going to mill this end into the part, mill one of these sides, and we can use these sides to indicate a parallel reference, so that we cut it into a perfect rectangular section. So we don't need this dial caliper as of now, or a dial gauge. So we are going to keep this aside. This is the freshly reground carbide end mill that we have. You can notice from the face that it has been reground because there is no coating, and it is a good end mill. We crashed it some time back, so we have to redo the end mill face, but the flutes are okay, and the flutes are the part which we would need for side milling. So we are going to install it. So all right, so let's start with the milling. We are going to touch off the part. So this is touching, this is Y0. Okay, we are going to give a depth of cut of 1 millimeter. All right, let's see how much this cleans up the face. Locking the table. Probably I believe the feed is too high. The surface finish, as you can see, is pathetic. We need to see to it why is it so, but other than that it is cutting. So this is conventional milling which we are doing right now. Let's see. All right, so let's give in 0.5 more. All right, and do a climb cut. I believe the surface finish is going to come out good right now because we are climb milling this. And it is coming good. Yeah, we are going to use some. Yeah, it's cutting good. Okay. All right, as you can see, if it is visible in the camera, I zoom you in, and it is already zoomed in. The surface finish, as you can see, has come out excellent. So we are doing the cutting now. The finishing seems nice. So this is the spring pass that we are going to give. It is cutting a little, and this would be our spring or the final pass. Probably we are going to give a little bit more. So we are going to go in 0.20 of a millimeter as our final pass. So this surface finish is okay with us. We are going to roll with this. This is the last pass that we are going to go on this side. Let me grab a picture for you so that you can understand better how the finishing is looking now. So here is the picture for you guys. So these are how the chips are turning out. Let me zoom out. These are how the chips turns out. They are very deadly, mind you, because they are very sharp and very thin. So we are going to dress this edge. Alright, so let's into the part now. So we are placing these spacer blocks or 1, 2, 3 blocks. These are also called parallels, because what would happen post this is that the burrs that we are generating on these edges, you can see clearly the burrs. All these burrs are going to interfere with the final product. So since we do not want the burrs to interfere, we are placing it over the machined sides and not over the burrs. So that's the idea of putting this 1, 2, 3 blocks here. Okay, so as you can see, this is the setup. It is held with the help of this strap clamp, only one side, because we are indicating the other side and the strap clamp is going to hinder it. The idea is that since this side is already been machined and this is straight, we can reference this side to machine this side, because this side, as you can see, is all rough, because this was a saw cut. You can see clearly in the camera, and this has no precision. So if we indicate this, then we can definitely go and cut this 90 degree, because the table is going to move, because we are indicating on the y axis and the table is going to move on the x axis. So currently it is in 20 and we are going to 0 it. So it is 0. So let's see how much deviation we are gonna get. So we are very close, and as you can see, we are not moving much. So it's negative 20,000, sorry, negative 0.02 of a millimeter, and we are already half there. So now it has gone to minus 5, minus 0.5, minus 0.6, minus 0.7, and we are at the edge, and we are currently sitting at minus 0.8. So we are going to bring it back to minus 4. So we have to tap the part. We are gently tapping it with the help of our mallet hammer. We are going the other way. All right. So last thing is we are going to just tighten this strap clamp a little bit and check the indicator to see we do not have a movement. Okay, we are not having a movement. So we are going to indicate this as 0 again. So it's 0. Let me zoom you guys in. This is at 0. This is the all the way we can zoom, but this is the 0 location, and we are going to move again. So the indicator is currently at minus 0.1, and as far as we go, we are again back to 0, and if we go further, we are still at 0. Okay, so this is indicated very accurately. It's showing 0, and the needle is not moving much. So this is okay, this is currently done. So now what we need to do is we need to put the strap clamp in. We are going to check the needle movement as well. If we have a needle movement, then we have a problem. Making sure that the indicator do not move. It's tight, relatively tight. Okay, so we are okay with it. It is plenty precise enough, and the customer did not have a requirement of this edges to be very accurate. They are only worried about the top. So the top is very precise, the sides are going to be equally precise, but we always try to over deliver to the customer so that the customer do not have any face any problems. Okay, so now we are going to touch off, but before we do the touch off, we are going to lock the knee in place. So the knee is locked. Okay, so this is the touch off, and it touched off on the bar, but that's okay. This is X0 and Y0. Let's go through the entire surface because there probably might be high spots we don't know about, and we might crash the mill. We don't want that, so we are not going to repeat the same mistake we did last time. Right now we are just milling the burrs off. That's what we are doing. So we are not touching anywhere. Alright, good. So we are going to give a depth of 1 millimeter. Probably the right direction would help a lot. So this is 1 millimeter depth of cut we are giving. We use some oil. Probably the better oil is gonna be this thick oil that we use. Alright. So we are going to again give a depth of 1 millimeter. This is cleaning the surface beautifully. The surface finish is great. Alright folks, so we are starting with the machining of this face, and this is how we are indicating this. As you can see in the camera, we have a dial test indicator over here which is currently at 0. We are going to bring you in close so that you can see while we indicate this. Now because this side has already been machined and this side has been machined, so we are using this as a reference plane. So if we now bring it in close and zoom you guys in, and we are going to put it to 0, which is 0 now, and if we go, we can barely see any run out. There is some. Alright, so this is negative 0.04 of a millimeter, and then if we go all the way on the other end, so here we are going to mark this as 0. We are going to mark this as 0. Alright, now if we go all the way, so we can see the needle is fluctuating, but it is more or less very much accurate. All right. So it's minus 0.6 of a millimeter out. Let me see if we can somehow manage that. All right. Let's just clamp it a little more. So right now it is plus. Okay. So again we are going to mark this as 0 and this is 0. Let's go back, and we think that we are dead on accurate. I hope it is visible in the camera. There can be some light issue but you can see the indicator is not moving at all, which means that we are very much parallel and accurate. We are trying to machine within reason, and 0.03 millimeters is nothing, which indicates 30 microns. That's okay. So we are going to take out this indicator and start machining on this side. So we are very close to 12 inches now. I just need to check. Okay, so it is probably a millimeter and we are done. More 1 millimeter to go. So now we are going to go 0.5 millimeters. All right. Probably the last pass is remainder. So this is 0.5 of a mil. Let's measure once more. We are gonna go half a millimeter and check once more. We are using this small scale, if you can see in the camera, as a stop, so that the scale did not over travel. We do not have a vernier scale which is 12 inches, which we could have used in this project, but if we don't have a vernier caliper, I think eyeballing it will just work. Probably we are going to go maybe 1 millimeter or more odd, but then we are going to go 0.5 millimeter and check. So here we go, another 0.5. As again, the sides are not critical, they just need to be within reason. So a 0.5 depth of millimeter cut, and we are done with this side mostly, I believe so. Okay, we might need a cleanup cut. Let's check where we stand. Yeah, so it is clean. So we are going to just do a scratch pass or a final pass without giving any further depth, just to clean the surface up. And because this is going to be our last pass, we are going to use some amount of oil such that we don't encounter any problem. So let's start. This is the last pass. So surface finish is coming out good. In fact, the surface finish, if I would say, is excellent. Excellent surface finish. For you guys, there is going to be a picture coming. So here is a sample picture of the surface finish that we have got. Alright, this is 12. Bang on 12. So we are done here. Let's undo the part one last time. We need to clean this mess up. So let's do this. We are going to meet once we undo this part around for one last time. Alright. So these are the last few passes. We are very close to 9 inch. We'll measure once this passes over. So let's check now. So this is as much as we would like to go. That's it. What we are only going to do is give a spring pass on the return stroke, and we are done. So use some light oil. We are not giving any further depth because we are exactly at 9 inches. The finishing seems very nice. So we will let this through and we are done. Yeah, exactly 9 inch. So for you guys, there is going to be a picture which we are going to provide just now, because you would also like to see if this is exactly 9 inches or not. So here is a picture, and let me see the picture as well. Dot in 9 inch. Alright, so we are done with this. So these are how the side looks. I hope it justifies on the camera. These are all the 4 edges that we have just machined, and this was machined before. So the final measurements, now as you can see in the camera, oh, you cannot see. So this side, this is a random side, and this measures 21.08. I hope it is visible in the camera. 21.04, 20.94. On this side it's 21.11, 21.11, and this is 21.05. We move it once more and we get 21.04, 21.08, 21.19. Again we move it, we get 21.11, 21.12, 21.27. There are some bursts. Yeah, we can see some birds it's cocking, but more or less dimensional accuracy has been 21, somewhere around 21, which was the tolerance which the customer has given. We are using some carb cleaner to clean this up, and we are ready to dispatch it to the customer. So with this part, with this we have officially been done with this aluminium fixture plate build, and we are going to send this stock to the customer at Mizoram. Now he is going to drill some bunch of holes, do fixturing on that, but that is not the scope of our work. That belongs to the customer, who wants to use it in whichever way they deem fit, because aluminium is not readily available in that part of our country. That is the reason why they are getting it done from us. So with that said guys, I hope this video was fun, this video was educational, and it was entertaining. I hope you guys would come to watch this particular video which is going to come next. This is going to be a stainless steel fixture plate or a stainless steel bulb housing. This is going to be a SS304 bulb housing which is made from solid stainless steel 304 blanks, which we have over here, solid SS304 blanks. But then more about that in another video. This is just going to be a teaser here, we are saying so that you guys subscribe to the channel and you would be notified when that video comes up. So that's it. Thanks a lot for watching. Hope to see you in the next video. Tab tak ke liye keep smiling and God bless.